If you are watching this video for the first time, make sure you are subscribing to Anantha Lakshmi Academy. Once you click on the subscribe button, you will see a bell icon. If you click on that bell and click on all, you will get to know whenever I upload a video. This will send you a notification. Hello everybody, welcome back to Anantha Lakshmi Academy. Today we are going to discuss the last conceptual part in trigonometry. What is it? Trigonometric identities. The topic today is trigonometric identities. In this video, we will be discussing the conceptual part. Later on, we can go through the exercise based on this. Alright, today's topic is trigonometric identities. As the name says, let us get to know what is an identity first. What is an identity? Let me give you an example. A plus b whole square. We have learnt in our 6th standard, a plus b whole square is equal to a square plus b square plus 2ab, or a square plus 2ab plus b square, however you have learnt. Alright, what is this? This is an identity, a proven formula which is known as an identity. If we are using an identity equation with trigonometric ratios, then that is known as trigonometric identities. Okay, so now the next question comes up. What are we going to implement a plus b whole square using trigonometric ratios? No, I just told you a plus b whole square just for the example sake. What is an identity? Anything which is proved as a formula, that is an identity. And if we are using trigonometric ratios in an identity to prove an identity, then that is known as trigonometric identities, and that is the topic for today. All right, so we are dealing with trigonometry. What kind of triangles are we dealing with? The familiar right-angled triangle. Right-angle triangle, we have theta. Quickly name them: A, B, C. Where is the right angle between the opposite and the adjacent? All right, so from here, what are the trigonometric identities that we are going to solve? Okay, let's go to them. What is the triangle? Right angle triangle. As per our famous mathematician from Pythagoras Theorem, what did Mr. Pythagoras say about the triangles, especially the right angle triangles? Hypotenuse square is equal to adjacent square plus opposite square. Okay, this is what we know from our Pythagoras theorem. Now, in order to get to the point of solving the trigonometric identities, let me solve all of them. I mean, divide all of them with hypotenuse square. Let's see what happens. If I am to divide this, divide both sides with hypotenuse square. All right, hypotenuse square by hypotenuse square is 1. Next, adjacent square by hypotenuse square is nothing but adjacent by hypotenuse whole square. Now, opposite side by hypotenuse square is nothing but opposite by hypotenuse whole square. So, adjacent by hypotenuse. From our trigonometric ratios first class, what is adjacent by hypotenuse? Cos, right? 1 is equal to cos square theta, since there is a square. Okay, opposite by hypotenuse. What is opposite by hypotenuse? That is sin theta. Since there is a square, it becomes sin square theta. This is the first identity of the trigonometry that we solved for today. What is this? Cos square theta plus sin square theta is equal to 1, or 1 is equal to cos square theta plus sin square theta, or sin square theta plus cos square theta is equal to 1. This is a familiar trigonometric identity which is going to be used in the next exercises, examples, and even in intermediate. You know, in intermediate you have around 3 to 4 chapters based on trigonometry, complete trigonometry. If you are familiar with all these identities, ratios, it will be a cakewalk for you. All right. Next, this is the first identity. In trigonometric identities concept, we are going to solve this section for three identities, just three identities. Okay, first, what did I do? I just divided it with the hypotenuse square. Now, let me consider this as equation 1. We are going to divide this by adjacent square. Let's see what happens when we divide this by adjacent square. Okay, what is one? Hypotenuse square, right? Hypotenuse by adjacent whole square is equal to, adjacent by adjacent is nothing but 1. Adjacent square by adjacent square is nothing but 1, plus opposite square by adjacent square is nothing but opposite by adjacent whole square. Okay, what did we do here? We just divided 1 with what? Adjacent square. Alright, that's what we have done. So, what is hypotenuse by adjacent? Adjacent by hypotenuse is cos. Hypotenuse by adjacent is secant, right? This is nothing but secant square theta is equal to 1 plus, what is this? Opposite by adjacent. What is opposite by adjacent? Opposite by adjacent is nothing but tan. Since there is a square associated, it becomes tan square theta. The next trigonometric identity is secant square theta is equal to 1 plus tan square theta. Alright, this is the second identity which is also used in the same sections which I have mentioned for the first trigonometric identity. Alright, now let us go for the third identity. See, now try to guess. For the first identity, I have divided it with hypotenuse square. For the second identity, we have divided this with adjacent square. Now what are we going to do for the third identity? Try to guess. Yes. Now we are going to divide this equation with opposite square and try to figure out the third identity. Alright. So let's do that part as well. Divide equation 1 with opposite square. Okay, what are we going to divide it with? Opposite square. Hypotenuse square by opposite square is nothing but hypotenuse by opposite whole square is equal to adjacent square by opposite square is nothing but adjacent by opposite whole square, and opposite square by opposite square is nothing but 1. Which implies, now let us try figuring out this. Hypotenuse by opposite. What is hypotenuse by opposite? Opposite by hypotenuse is sine. Hypotenuse by opposite is nothing but the multiplicative inverse of sine, which is nothing but cosecant. Since there is a square, I am writing it as cosecant square theta is equal to 1. Adjacent by opposite. What is adjacent by opposite? Opposite by adjacent is tan. Adjacent by opposite is multiplicative inverse of tan, which is nothing but cot, plus 1. Here we are with the third identity. So what is this? Cosecant square theta is equal to 1 plus cot square theta, or cot square theta plus 1. In fact, if you get this cot square theta this side, cosecant square theta minus cot square theta is equal to 1. And here, if you are solving for 1, secant square theta minus tan square theta is equal to 1. See how simple it is? Identity. What is trigonometry? What are we going to discuss? What we have discussed here is that trigonometric identities. First, we have discussed what is an identity. Identity is nothing but something which has proved as a formula. And when we are dealing with trigonometric identities, we are trying to figure out the trigonometric ratios in an identity. So that's what we have solved for. We took the Pythagoras theorem and the familiar right angle triangle that is associated with trigonometry. So what have we done? We took the Pythagoras theorem. Hypotenuse square is equal to opposite square plus adjacent square. Then it's so simple that you have just 3 sides of a triangle. You have to divide this equation with one side of a triangle at a time. First, we have divided this with hypotenuse square, the whole equation with hypotenuse square, and we got what cos square theta plus sin square theta is equal to 1. Then we have divided the entire equation with adjacent square, and for adjacent square we got secant square theta is equal to 1 plus tan square theta. And for the last one, we have divided the same equation with opposite square, which resulted in cosecant square theta plus cot is equal to cot square theta plus 1. So this is the conceptual part of trigonometric identities. Quite simple, isn't it? So once you are thorough with this and you understood this, I strongly recommend you guys, as usual, to go through the examples so that we'll be solving in the next part, the exercise part, which is 11.4, which has around 10 problems, I guess. If you understand this concept and the identities, whatever we have derived so far, the three identities, it's just quite simple, right? The three identities. If you remember this and if you practice the examples, then we can get started with the 11.4 exercise. So if you like the explanation and if you feel that the content is worth enough to listen and understand, please do like, share and subscribe to Anantha Lakshmi Academy. Thank you.